Okay, this is January 2016, paper 2. This is question number 1. Which of these is a vector quantity? So same thing we always do, we go through them. Vectors, remember, have a magnitude, very slow pen, and a direction. So which of these four have a magnitude and a direction? So something like speed. Now speed, we know it is not a vector because it only has a magnitude. With speed, you don't have to say which direction it's going in. When we put a direction on it, we call that velocity. Mass as well. We don't need to say what direction our mass is in, it's just the size of the mass. Density too, because something is a density, it has a density, it doesn't have to be in any particular direction, so that leaves, it has to be force. Which of these is a scalar quantity? So scalar just has a magnitude, acceleration has a direction. We're interested in which way that direction is for acceleration, so it's not that one. Momentum, that also has a direction. It can either be positive or negative, showing it's either going to the left or the right. And as we just said, velocity is not a scalar, so energy is the scalar here. When a book from a low shelf is placed on a higher shelf, the book gains, well, it can't gain mass, it doesn't gain weight because it's on Earth, and weight is just given by W equals mg. It can't gain work. Some work is done to something. Remember that work is force times distance. So the book doesn't gain work, but it does gain gravitational potential energy, which is given to us by mgh. When an object falls at terminal velocity, does it accelerate at 10 meters per second squared? Well, at terminal velocity, terminal means stops, so the velocity stops. The velocity in this case stops increasing. So it wouldn't still accelerate. So it wouldn't do that one. It doesn't have no weight. That doesn't make sense. It still has a weight, which is why it's still dropping. The resultant force is downwards. So here, if you have terminal velocity, there is no resultant force because the forces on the object are now balanced. So if there is no force, there is no acceleration. So if there is no force, there's no acceleration, so it goes to terminal velocity. So it can't be C, which leaves it to be D. The vertical forces on it are balanced. There is no resultant force because the forces are balanced, so it will stop accelerating and it's reached terminal velocity. That's question number 1.